Hi, this is Mrs. Thompson. We're back again with lesson 3.1 for Math 8. Some of our key vocabulary and terms that we're going to be talking about tonight are equivalent equations. Equivalent equations are equations that have the same solutions. You can see up above here in this model, x plus 3 equals 5. X is an unknown. We have 3 ones, and over on this side we have 5. We always want to keep our scale balanced. So whatever we do on one side, we have to do on the other. If we take 3 cubes away on this side, we have to take 3 cubes away on this side of the scale, which leaves us with the equation x equals 2. What we're going to be doing shortly is showing x minus 3. And I know most of you know in your head the answer is 2 plus 3 is 5. We need to show the inverse operation, which we'll talk about shortly. An inverse operation. What does that mean? Inverse means it undoes. If you think about our inverse property of addition, that's when we added two things that were opposites. So addition and subtraction are called inverse operations. They undo each other. When we think about the subtraction property of equality, it says that subtracting the same number from each side of an equation produces an equivalent. So if you were looking at your notes, you might have put this in your notes for subtraction property of equality. What does that mean? We need to show the opposite of adding 5, which is to subtract 5. They showed it here on both sides of the equal sign. When we do that, we're left with x is equal to 2. X equals 2 and x plus 5 equals 7 are equivalent equations. Algebraically, it looks like x plus a equals b. We're going to subtract a from both sides to get an equivalent equation. Addition property of equality, adding the same number to each side produces this equivalent equation. So if x minus 2 equals 6, some of you might be thinking in your head, oh, I know what I subtract from 2 and get 6. I subtract 8. And by doing the inverse operation, we add 2 to both sides of that equation, and x is equal to 8. Again, this should be in your notes. If you need to pause, do so. In example 1 in your notes, x plus 8 equals 15. How do we make sure we do the inverse operation? Some of you might be thinking, oh, I know 7 plus 8 is 15. But that is 15. We want to get negative 15. I like to circle the variable I'm trying to get by itself. I want this 1x all by itself. How do I get rid of plus 8? I'm going to do the inverse, which is minus 8. Oh, you got to be careful here. X is equal to, what if we have a negative 15 minus 8? If you remember, we talked about saying negative 15 minus 8 is the same as plus the opposite, which is going to be plus a negative 8. Negative 15 and negative 8 add to give us a negative 23. Oh, I thought it should have been 7. Well, when we do our check, we go back to the original, x plus 8. The question is, does it equal negative 15? And if we plug in negative 23 plus 8, that does equal negative 15, and it checks. What about c minus 4.5 equals 13? Again, circle what we want by itself. I want c all by itself. The opposite of minusing, add 4.5. Now someone will say to me, but Mrs. Thompson, I thought you said subtraction always changes to add the opposite. So could we rewrite this problem as plus a negative 4.5 equals 13? You could. How do you get a 0? We're still trying to get c by itself. What do you add to negative 4.5 to get it to be 0? You add 4.5. So both ways you're still adding 4.5. In both cases, 17.5 is our solution. X is equal to 17.5. We want to do a check. What does it mean to check it? Check means go back to the original. Now my youngest is sitting right next to me as I'm recording this. Sophie, what did I just say x is equal to?
17.5.
So I plug in 17.5 for c. Minus 4.5 equals 13. The question I'm gonna ask you is who was sitting next to me when I recorded this video and see if you got it down. In this case, does it equal 13? It does. Tomorrow you can tell me her name. What about climbing a rock? If we're climbing this and we're using a model, how can we model it? Well, if we've gone 675 feet, we're gonna go x plus 675. How high are we trying to go? 1,500. What does x stand for? X is how much farther we have to climb. So how much, my writing is tough on this guy, how much farther we have to climb? Now, we should have our answer in feet when we answer it. The opposite of adding 675 is to subtract 675. X is equal to, when we subtract 675, we'll have 14, 9, 10, 10 minus 5 is 5, 2, 14 minus 6 gives us 825 feet. You would then want to write this in a sentence. What about a situation where you have something like 5 minus x is equal to 7? Now some of you might be thinking in their head, oh, I know what this is. But what if we make it a negative 7? It makes it a little trickier. Again, we want to isolate the variable. I'm going to rewrite our subtraction as plus a negative, and I'm going to put a 1 in front of my x. This is what I want by itself. How do I get rid of this 5? Someone said I should add 5. Well, if I add 5 to this side, 5 plus 5 gives me, Sophie,
10.
I don't want 10. I want to get a 0 here. So I can't add 5. I have to add a negative 5. Or, if I wanted to think of subtracting 5. If I subtract 5, I'm left with 0 on this side. Subtracting 5 on the other side, a little trickier, negative 1x. If I have negative 7 minus 5, that's going to be the same as negative 7 plus the opposite of 5. And negative 5 gives me negative 12. Some of you were thinking this should have been 2. But think, 5 minus 2 doesn't give us negative 7. We're going to divide both sides by negative 1. And x is equal to 12. Does it make sense if we check it? The check says 5 minus the original equation was x equals negative 7. So 5 minus 12, does it equal negative 7? I'm going to rewrite this as 5 plus a negative 12. 5 plus a negative 12 is negative 7. So this problem checks, and my solution is 12. As you do your problems, make sure you're showing your work, make sure you check. If it helps you to circle what you want by itself, circle that. You're always doing the inverse operation with what's with your variable.